Hello and welcome to AC analysis of a MOSFET amplifier video tutorial. Please pause the video and take a few moments to assemble the following circuit. We will be using M-Break N3 model for our MOSFET and DC voltage source and also V-Sine voltage source. So let's have a value for our VDC biasing of 10. Our load resistance is going to be 10K. Our capacitance will be 10 microfarads. R1 is going to be 5K, R2 is going to be 71K, R3 will be 29K, our another capacitor will be 10 microfarads, and our resistor, the source resistor, will be 4K. So our voltage sine source will have offset of 0. The amplitude will be of 0.01 volts or 10 millivolts, and frequency 1000 Hertz. So let's edit our PSpice model. Our threshold voltage will be 1.5 volts. Our KP is going to be equal to 0.1 milli, and our length will be 1 micro and width will be 10 micro. Now let's save changes and close the window. Now let's go to and create a new simulation profile. So we'll hit create, and our runtime will be 10 milliseconds, so we can get 10 cycles, and our maximum step size will be 0.1 milli. And please be sure to go to the options and include the detailed bias point information. Okay, let's put our probes on the load resistor and on our source and run the PSpice simulation. So in this we can do and go ahead and view our output file. And if we scroll all the way down, we can see our operating point, ID, VGS, VDS, and our GM is 1.4 milli. So right now let's go and hit a curve tracer and go a cursor peak, and here we'll see the peak of 39 millivolts approximately. So our gain is 3.9. Let's now measure the input impedance of our amplifier. Let's go ahead and change 4K resistor to the value of 21.2K, and we'll delete the pins right now and put the voltage pin right in between resistor and the capacitor. And let's run the simulation. As you can see, we're using basically our amplifier, and the resistor is a voltage divider, and right in between our voltage is 5 millivolts, which is half of our input voltage. So it means that our input impedance is basically equals to the impedance of our resistor, which is 21.2K. Let's now go back to our previous setup, and we'll just change our resistor to 4K, back to 4K, and we'll go and change our load resistor to 100 meg, which will simulate our open circuit. Let's go ahead and run the simulation. Now we can see that our go to measure the peak, so it's 58 1.5 millivolts approximately. Now let's go ahead and change it to our output impedance, which was approximately 5K. Now let's go ahead and measure the peak voltage, and we can see that it dropped down in half. So using the idea of the voltage divider, we can tell that our output impedance is actually about 5K. Now let's take a look at a lambda parameter. Let's go and edit PSpice model, and we'll just introduce the new parameter called lambda. And we'll get the value of lambda to be 0.01. Now, since we introduced this parameter, our output impedance will be slightly less. It's going to be 4.8K. And let's go and run the simulation. And right now we can go ahead and measure the peak, and it stays the same. So, and we can go ahead and view our output file. And if we scroll all the way down to the operating point in our output file, we can see that ID, VGS, VDS values changed. Also, value of GM changed from being 1.4 to 1.47 milli. This concludes our tutorial. Thank you for your attention.